Hello everyone. In this video we're going to finally get to use all the factoring techniques that we have been developing to solve some higher order equations, and we're going to do so utilizing a very important property of numbers called the zero factor property, and of course together with the techniques of factoring that we have been learning over the past few videos. I had mentioned previously that the biggest reason that we do learn the technique of factoring because it will enable us to solve equations that we would not otherwise be able to solve, and we'll get to see that in this video. The so-called zero factor property, we'll refer to it as ZFP from here on, is a very simple but extremely important property. It basically states that if you have a product of two numbers, say A and B, or they could be two expressions, makes no difference, is zero, then either the first number or expression must be zero, or the second number or expression must be zero. And of course, this or here is an inclusive or. That means it could be either this or that or both. When we use or in plain English, it usually is an exclusive or. For example, if you say tonight I'm either going to go to the basketball game or I'm going to go to the new live production of Beauty and the Beast, for example, you don't mean you're going to do both. You mean I'm going to do either this or that, but not both. That's what we mean by an exclusive or. When we use or in mathematics, it usually is an inclusive or unless otherwise specified. So basically, if a product of two numbers or expressions is zero, one or both need to be zero. There is no way you can multiply two numbers, neither of which is zero, and end up with zero. That's the essence of the zero factor property. So it's also called the principle of zero product. You may see that name. I wanted you to be familiar with that version as well. In modern language, we usually refer to it as ZFP. Modern, of course, by our standards. Maybe if somebody watches this 200 years from now, it won't seem modern anymore. All right. The procedure for solving higher order equations is different from the procedure for solving linear equations. If you recall, to solve linear equations, we basically simplify both sides, separate. What do we mean? We mean get the variables on one side, the variable terms and the constant terms on the other side, and then we proceed to solve. With higher order equations, the procedure is different. We're going to move all the non-zero terms to one side and get zero on the other side. Which side we do that on doesn't matter. Then we simplify and fully factor the side that isn't zero, so we say the non-zero side. Then we're going to apply the zero factor property and then solve the resulting equations. Let's see it in action. So in this first example, actually most of the steps here are done for us. All the non-zero terms are on one side, zero is on the other side, so step one is taken care of. Simplify and factor the non-zero side, that's already taken care of. And now we're ready to go ahead and apply the zero factor property. So we have 3x times x minus 5 equals 0. So we can consider, remember, the zero factor property says a times b equals 0 implies a equals 0 or b equals 0. Okay, very simple, very powerful. Notice that here you can consider, for example, 3x to be a and x minus 5 to be b. So now we're going to say either a is 0, so 3x is equal to 0, or we usually just use a comma. Even though logically speaking a comma stands for an and, we don't take that too seriously, and we go ahead and utilize it anyway. So now we set each of these equations equal, well, they're equal to 0, but we go ahead and just solve these two simple equations. So for the first one, we see that we need to divide both sides by 3. So we end up with x equals 0. Here the x's cancel out. 0 divided by 3 is of course 0. On this other equation, we just add 5 to both sides or move -5 to the other side. So we get x equals 5. So notice that, just to quickly check it, notice that if you plug in 0, that makes this factor 0. 3 times 0 is 0, and then we don't really care what it makes this factor, because 0 times any number is 0. So this would make it true. Now if you plug in x equals 5, it makes this factor, this binomial factor, 0, because you have 5 minus 5, which is 0, and we don't care what it does here. Well, it's going to give you 15, but we don't care about that because 0 times whatever is 0, so that makes it true as well. So the solution set is going to contain two values in it, 0 and 5. When you write the solution set, you don't need to write the x. You just write the numerical value of the variable that makes the equation true. In this case, the variable is x. That's like as simple as a problem as we're going to get. Notice this is a higher order equation, even though it looks like this part is linear, this part is linear. But remember, if you multiply that out, you get 3x squared minus 15x equals 0. Now you can see, by higher order, we just mean there are terms in it that are higher than first degree. So in other words, if all the terms just had x's in them, then it would have been a linear equation. But notice there's a square term. That's what makes this equation a nonlinear equation. All right, so here we have another equation. It looks a little bit more complicated than the previous one, but it's in the same format. In other words, step 1 and 2 have been taken care of for us. The variable terms are all on one side, 0 is on the other side, and this side is simplified and fully factored. So we're ready to apply the zero factor property. Again, you can think of this expression as A, and you can think of this expression as B. So therefore, by the zero factor property, we get that either 4y minus 5 is 0, or 3y plus 2 equals 0. So now we get 4y equals 5, so y equals 5/4. Remember, after you apply the zero factor property, you're going to get two simple equations out of the application, and then you'll just solve those equations. That's what we mean by solve all resulting equations, because you may even have more than two equations at this point. All right, so the second equation, we have 3y equals -2, so y equals -2/3. So if we go ahead and write the solution set, that it would contain, again, sets are not ordered. I could have put the 5/4 first and then comma -2/3, just out of convention, and just so that, for example, if we all agree to do this, then all our answers will look the same, and it'll be easy for us to check with one another whether we have the same answer or not, is if we agree to put them in ascending order from small to large. But At the same time, it's extremely important to realize you don't have to. In other words, sets like of this kind, where we're just putting objects in them, they're just a collection of well-defined objects, so they are not ordered. Now, for example, if you're dealing with an ordered pair, that's an ordered entity, but not a regular set, such as a solution set. I could have put 5/4 first and then negative 2/3, and that would have been just as correct an answer. All right. So here, it looks like we do need to do a little bit more work. We're going to move all the non-zero terms to one side and get 0 on the other side. So I have these two here already. I'll just bring -4 over to join them. So remember, we accomplished that by adding 4 to both sides, which is the same thing as saying move -4 to the other side and change the sign. Remember the all-important shortcut we had from elementary algebra: change sides, change signs. That's with respect to equations. With an equation, you know, you can take any term of an equation and change its side. In other words, look at this -5x. It's a term on the left side, right? You could move that to the right side as long as you change the sign to +5x. Why? Because that would be the same thing as adding 5x to both sides. So now we're dealing with -4, right? We're going to move it to this side. So we're going to add 4 to both sides, or we can just use the change sides, change signs shortcut, which says, hey, you want to move -4 to the other side? That's okay, as long as you change the sign to +4. But it's extremely important to know why that works and not just to do it blindly, right? Just because somebody tells you, hey, change sides, change signs. No, shortcuts are okay as long as the regular paths are understood first. So you don't want to go to a new town and only learn shortcuts, do you? No, first you want to learn the structure of the whole town, and then after, you know, a while, when you go through the neighborhoods, you learn some shortcuts, you create some on your own. But they should not be what you start with, because otherwise you won't have an overall understanding of the terrain. Same goes in mathematics. All right, so we're going to keep x² minus 5x on the left side. We're going to move -4 to the other side, which becomes +4 equals 0. So now we have all the non-zero terms on one side, and we have 0 on the other side, just as the instructions tell us to do. So now we're going to simplify and fully factor this side, the non-zero side. Notice that this is pretty simple, so the only thing left is, at this point, go ahead and see if we can factor it. So that's a quadratic trinomial. We spent a couple of sections on those, remember? Two numbers whose product is x², so that would be x. Two numbers whose product is +4, but whose sum is -5, right? So I think you'll agree that -4 and -1 should fit the bill. By the way, since the coefficient here is 1, we could use our big cross diagram. We're looking for two numbers whose product is +4 and whose sum is -5. Since you want the product to be positive but the sum to be negative, they both have to be negative, right? So that's where -4 and -1 pop in, okay? Notice their product, that means when you multiply them, what do you get? You get +4. Their sum, that means when you add them, you combine them, you get what? You get -5. So those are our numbers, okay? So now we're going to quickly check. First times first is first, last times last is last. Inner product is -4x. Outer product is -x. Notice they add up to give you -5x, which is the middle term. You never do a factoring like this and not do your three-step check, because you always want to get the right answers, don't you? Okay, so now we're going to go ahead and set each of these factors equal to 0. So applying the zero factor property once again, we get either x minus 4 must be 0 or x minus 1 is 0. Remember, if a times b equals 0, then a equals 0 or b equals to 0. Now solving those two simple equations gives us x equals 4 or x equals 1. Okay? Now, anytime that you have the luxury of extra time, you should check your answer. So, for example, to check 4, we're going to go ahead and plug in 4 instead of x in this equation. So we're going to do a substitution of 4 for x. See if it makes the equation true. To check, you always go to the original equation, not some secondary equation after you've done any kind of manipulation, because you're trying to solve the original equation. So you want to make sure that you have actually solved the original equation. So we get 4 squared minus 5 times 4. We're checking to see if that's equal to negative 4, right? Notice the question mark. That's because we're checking. We're not asserting. So we get 16 minus 20. We want to know if that's equal to negative 4. I still have the check because, yeah, you're thinking that's true. But next step, we're actually going to write an identity, which is we get negative 4 equals 4. That's when we agree that we have verified that the equation is true. So therefore, negative 4 is indeed a solution. Be careful, this is the end of your check. That's not the solution. The solution comes from here. All right, now let's go ahead and check x equals 1. So go ahead and plug it into the original equation. Remember our deal. Anytime you think you should be able to take something and do it from some point by yourself, pause the video and do it on your own. That's the only way you're going to get really good in math. All right, so here we get, it's whiteboard. These whiteboards are a little unruly compared to my classroom boards. Okay, so we have 1 squared minus 5 times 1. We want to know if that's equal to negative 4. So we're going into the original equation and we're plugging in 1 for x, right? Because we're checking if x equals 1 is a solution. All right, so 1 squared is 1. Negative 5 times 1 is just negative 5. So you get 1 minus 5. We're trying to see if that's negative 4. We notice that negative 4 is indeed equal to negative 4. This one checks out too. So now we can confidently say the solution set contains the numbers 1 and 4. And that's how we leave our answer. So here is another factor. Another equation that we can solve by factoring. So let's go ahead and listen to the instructions. We're going to move all the terms to one side. All right. Notice simplify and fully factor. That there's a lot contained in that word simplify, because when I look at this equation, something catches my eye, namely the fact that I have an even number, even number, even number. So I know at the very least 2 will go into all of them. And of course on the other side I have 0, and I know all numbers except 0 itself go into 0. So part of the simplification process is going to be, I'm going to divide both sides by 2 to get rid of that factor of 2 that's common to all of them. Because the 2 is not being just factored out, but actually going to be divided off the equation, that's precisely the terminology that we use. Since it's going to go away, we say divided off the equation. Normally we don't say the equation, we just say divide off the 2, the common factor 2. Now, One word of warning is you do this only with constant GCFs, okay? You never ever divide off a variable GCF. We'll see in a minute why you don't, but just take my word for it at this point. You do not divide. If I had a common factor of 2u, I wouldn't have gotten rid of it like this. And you'll see in a minute why you shouldn't, all right? Because you lose solutions basically when you do that. So remember, that's going to split these up. So basically each of those numbers is going to get divided by 2, right? So sometimes the way I show this for better cross-canceling capabilities, I just go ahead and throw a 2 under each term because I know that split is going to happen anyway, right? So when I have it like this, it's easier to cross-cancel safely. So here I know 2 and 4 are going to cross-cancel. 2 goes into 2 once, into 4 twice. These 2 will cancel completely, just leaving ones. 2 and 42. Remember, I'm not dealing with the signs. I'll take care of that in the next step. So if I say 2 and 42, I realize that's negative 42, but I'll handle the signs in the next step. So 2 goes into 2 once, into 42 21 times. So now carefully we write down what's left. So we have 2u squared minus u minus 21 equals 0. Okay, so now we have all the non-zeros on one side and 0 on the other side. So we're going to go ahead and factor. Now this time, even after getting rid of the common factor, our lead coefficient a, which is 2 here, is not 1. So we don't use the cross diagram, remember that. So we're just going to do it by trial and error and FOIL, right? So we want 2 expressions in here and here whose product is 2u squared, right? So that's going to be easy, maybe 2u and u. Now here in this spot and this spot, we want 2 numbers whose product is negative 21, and then we want to make sure the outer and the inner products add up to the middle term. So let's try. As you know, with these, I don't start out with any signs other than just the numbers. So then we'll deal with the signs later. So I noticed that maybe if I, 21, perhaps 3 and 7, maybe, right? So 3 and 7. Now the inner product here is going to be 3u, right? The outer product is going to be 14u. I want to be able to combine those and get negative u, right? That's what I want. Notice that can't happen because there's no combination of 3 and 14 that's going to give you negative 1, right? So do I give up on 3 and 7? Not yet. Remember, you always have to try it the other way around because that'll give you different results. So we'll try 7 here and 3 there and see what happens. So now the inner product is 7u. The outer product is 6u. Now, can I combine those to get negative u? This time, of course, it is possible to get what we want, which is negative u, from 6 and 7. Of course, we can get it if the 7 is negative and if the 6 is positive. So we'll have negative here and positive here. So let's quickly do our 3-step check. First times first is first. Last times last is last. And we notice that the sign works too. Negative times positive is negative. The inner product is negative 7u. The outer product is positive 6u. They combine to give us negative u. As long as you have checked all three of those facts, you can safely move on because you factored it correctly. When you get good at these, it literally takes you 5 seconds to do that check, but it'll save you an entire problem, and you'll always get it done correctly. So now we're going to apply the zero factor property, and we get either 2u minus 7 equals 0 or u plus 3 equals 0. So we get 2u equals 7, so u equals 7 halves, or u equals negative 3. And definitely, if you have the time, check these. It's great practice with arithmetic skills anyway. So here we get s equals negative 3 comma 7 halves, right? All right. So even if we don't have a time for a full check, we can always do a quick calculator check, see if it works out. So remember, we're going to plug into the original equation. Our video would be far too long if I wanted to do all of that manually, so let me just at least show you the verification. So we have, on the left side, we have 4u squared, so 4 times negative 3 squared. All right. Oh, not like that. We need to go back and fix that. All right, let's do this. Let's start from scratch. This calculator can be a little bit touchy. It's a great machine, but all right, so here's the problem. Once you hit that open parentheses, it automatically creates a close parentheses. So I had to exit and then square. All right, so notice that we get 36 for this expression when we substitute negative 3. Let's see what we get when we substitute negative 3 on this side. So we have 2 times negative 3, and then we're gonna remember exit out of there, and then add 42. And notice, so we get the same thing when we plug in negative 3. So now what we're going to do is we're going to go ahead and plug in 7 halves. Let me see if I can show you a trick which works with some of these nice modern calculators. Notice that if I just go there and hit enter, it's going to replace that. I mean, it's going to copy and paste that. So here, if I go here and I get rid of that, I can replace it with 7 over 2. See? It saves me a lot of writing. Okay, so I get 49. Now, if we copy this and do the same thing, go replace that negative 3 with 7 halves. See, you have to have some of these good computing skills as you proceed anyway. Notice both gave us 49, so that means plugging in 7 half in here also makes the equation true, because you'll end up with 49 equals 49 when you go through the simplification. All right, so there is that. Let's see if we can do another one. All right, this procedure we have outlined needs to be applied anytime you have a higher order equation. That means any equation that has any power in it which is higher than just the first power x. So in other words, even this right here is considered a nonlinear equation because it has an x squared in it. And just because it looks simpler than some of the other ones, we don't treat it any differently. we're going to do all these steps. We're going to move all the non-zeros to one side. So we end up with 4x squared minus 25 equals 0. Now we're going to simplify and fully factor. Notice that there's nothing to really simplify here. There's no common factor or anything like that to take out. So we'll go ahead and factor. We do notice we have a difference of 2 squares, right? Remember the rule? F squared minus L squared equals F plus L times F minus L. Now, what's playing the role of F here? In other words, what do you have to square to get 4x squared, right? Yeah, I think I heard you say it, 2x. And what do you square to get 25? See? Yes, I think I heard you again, 5. Okay, that's good. So now you should pause the video, go finish it. You know what to do now. Factor it using that formula, then apply the zero factor property. All right, so not ready for that yet. So I'm going to factor the left side. So I get F, which is 2x, plus L, which is 5, times F, which is 2x, minus L, which is 5. Don't forget, and this is a common error, that equals 0 must be written down again. Because if you don't write the equals 0, which is a common mistake a lot of students make, you have suddenly demoted an equation down to the level of an expression. An equation has to have two sides with an equal sign separating the two sides. But you have to have expressions on both sides. So you can't just suddenly drop the equals 0, because if you do, then you won't be able to apply the zero factor property anyway. Zero factor property says if A times B equals 0, then A equals 0 or B equals 0, right? So now we apply the zero factor property. So either 2x plus 5 equals 0 or 2x minus 5 equals 0. Let's move the 5 to the other side, becomes negative 5. So we get x equals negative 5 halves. So you get 2x equals 5, and you get x equals 5 halves. So in the later chapters, when we cover quadratic equations in more depth, we'll find another way of dealing with these as well. But for the time being, this is how we're going to approach these. All right, so we could do a quick check. Let's do it by hand this time, so that if there are any purists watching this, they won't get too upset. All right, so 4 times, we're going to plug in negative 5. We're going to check this one, right? Negative 5 halves. By example, actually I meant check. All right, so negative 5 halves squared. We want to know if that's equal to 25. Question mark, of course, because we're checking, we're not asserting. So 4 times, now we know negative 5 squared is just going to be positive 25, and we know 2 squared is 4. So we want to know if 4 times 25 over 4 is 25. And of course, 4's cancel out, you do end up with 25 equals 25. Once you get this identity, an identity is an equation which is always true. So any time you have some number equals to itself, right? You know that that's going to be an identity. So once you hit this identity with just constants in it, we know that we are finished verifying and that the number that we substituted for x has made the equation true. So then you can check. So I'm going to leave this for you to do. Go ahead and check x equals 5 half as well. You'll see that the same thing will hold. And then we can write our solution set. So we get negative 5 halves, comma, 5 halves. in some classic textbooks, you may see the solutions, like if you're checking the back of the book, you may see the solutions written like this. All right. Now, in more modern mathematics textbooks, we usually go with this, just because when we did this, some students didn't realize these are actually two different solutions. Now, whenever you're dealing with two different solutions, but you're only dealing with one variable, right? You do not use parentheses around those. Be very careful not to do that, because usually systems like my MATLAB will provide the braces for you. You just have to type in the answers. When you type those in, you don't want to contain those within parentheses, because if you do, you're saying that's an ordered pair, which indicates more than one variable. So remember, whether you use parentheses or not depends on your number of variables. Are you getting different solutions for the same variable? See, x equals, it's the same variable. Then there is no parentheses needed, because this is not an ordered pair. These are independent solutions for the same variable, right? For the same equation and the same variable values that satisfy it. Now, if you had an ordered pair situation where you had more than one variable, such as with systems of two equations and two unknowns, then you would want to contain those solutions which are in the form of an ordered pair within parentheses, but never with these. I make a big deal out of this because that's a very common mistake. Students get two numbers, they feel like they need to put those together in parentheses, which is not the case when there is only one variable. All right, you should be able to do this one on your own for sure. Definitely pause the video and then go ahead and come back to the video after you try it on your own. All right, so welcome back. We're going to go ahead and move all non-zero terms to one side. Remember, always follow the instructions. Now, that's the correct approach. And you end up with, now we're going to factor the left side. Notice the GCF is x. So we're going to factor out the x. That leaves us x squared minus 9 equals 0. So now we notice that here we have a difference of squares, which we can factor again. So we know that f squared minus l squared equals f plus l times f minus l. And here we know the role of f is being played by x and the role of l is being played by 3, right? So we get x times x plus 3 times x minus 3 equals 0, right? So we end up with 3 factors whose product is 0. So you apply the 0 factor property with 3 factors. So you say either x is 0, the first factor, and this is the one a lot of students miss, so be careful, or x plus 3 is 0, or x minus 3 equals 0. So the first one you're done with. The second one you get x equals negative 3. For the third one you get x equals 3. Notice that you have 1, 2, 3 solutions here. All right, so when we write the solution set here, which is of course actually easy to check, right? Look, plug in 0. What happens? You get 0 cubed, which is 0. 9 times 0 is 0, so you get 0 equals 0. Plug in negative 3, so you get negative 3 cubed, quantity negative 3 cubed. The negative is being cubed as well, but you still get negative 27. And on this side, you have 9 times negative 3, which is also negative 27. So you get negative 27 equals negative 27. Plug in 3, and you get 3 cubed is 27. 9 times 3 is 27. So again, becomes true. So you write your solution set. Now, if you're going to go by the convention of writing things from smallest to largest, then you would, of course, put -3 first, then 0, then 3. But also, always remember the order is not mandatory. I mean, you could have put it in any order, these three numbers, and it would have been correct, right? We just do this because one, looks kind of nicer. Two, if we're all going to agree to do that, then all our answers and solutions will look the same. All right, so there's another equation that we were able to solve using factoring. This one was a cubic equation. It's a third order equation. All right, so here's another one for us. Go ahead and try this. Definitely try it and don't give up too quickly. All right, so we're going to move all the terms to one side, right? Now, we could take them all to the right side, or we could take them to the left side. Well, usually the way I like to decide that is, where is the highest order term? I noticed that it's over here. Now, if the highest order term had a negative coefficient on that side, I would have moved it to this side to make it positive, right? But I noticed that here it has a positive coefficient. It's sitting pretty comfortably there. I'm going to leave it where it is. So I'm going to leave the 4x to the 4 on the right side. So that means we should go ahead and keep this one here too and move this guy over, right? Notice that x cubed should come before x squared if you're going to write them in descending order to make factoring easier. So that's what we're going to do. We're going to write -24x cubed next, and then plus 36x squared. And of course, since what we have done is we have subtracted -24x cubed from both sides, that's going to leave us 0 on this side. All right, now we're going to factor this out. But before we do, I want to go back to the previous problem to show you why I had warned you about something. All right, I know that when we were solving this and I moved this to the other side, the 9x, I know that if you would be honest with yourself, at least a few of you, because I know I was tempted to do this when I first saw these two, we figured, why don't we just divide both sides by x and get rid of the x? But remember, I had given you a warning in the previous screen. Let's go there. I should have said 2 screens ago. Notice, I said never divide off, meaning never divide both sides of an equation by anything other than a constant like this. Of course, you never divide by 0, but any constant other than 0 is okay. You just never divide by a variable. Okay, here we're going to see why. All right, so let's do a what if. What if I did that? Okay, in other words, what if I took x cubed equals 9x and I went ahead and divided both sides by x, right? You're going, that seems pretty reasonable. So I end up with x squared equals 9. And I'll move the 9 to the left side now, and I'll factor. So I get x plus 3 times x minus 3 equals 0. So then I'll go ahead and apply the 0 factor property. Hey, you're thinking, hey, this all looks pretty kosher. What's wrong with this, right? Well, what's wrong with it is the fact that if you notice, by doing so, by dividing both sides by x, I actually divided off one of my potential solutions, which was 0, right? So getting rid of a variable from both sides is simultaneously going to get rid of at least one of your solutions. So you never want to do that. You never want to divide both sides by a variable. So this what if is not good. We're not going to do that because we saw what happened. We end up losing solutions. So we will not divide both sides of an equation by a variable. That brings us back to our current problem. The reason for all that long speech was the fact that, notice the GCF here, we can do better than just a number. The GCF is 4x squared, right? Now, even though you shouldn't divide off the x squared part, you definitely should go ahead and divide off the 4 part right away, because the rest of the problem will be much easier to handle if you do that. And that is always safe to do with constants, okay, other than 0, of course. All right, so that's what we're going to do. And remember, once we divide the left side by 4 and the right side and the left side by 4, these are going to split up, so we might as well split them up from the get-go. So we're going to get this, and on this side we have divided by 4 too. Of course, 0 divided by 4 is 0. Okay, if you don't have any money, you can give each of your 4 friends the same amount, exactly 0. That's never a problem. Now here, we're going to go ahead and simplify. So we just get 1x to the 4, which is x to the 4, minus 24 divided by 4 is 6, so minus 6x cubed. And 36 divided by 4 is 9, so plus 9x squared, right? So notice our numbers became quite a bit nicer. And we haven't done anything illegal because we didn't divide by any variables, right? So now what we'll need to do is we need to factor out the remaining variable GCF. So we get x squared, we factor it out, that leaves us x squared minus 6x plus 9, right? So now we notice that, hey, this looks familiar. We should be able to factor this, right? Well, you should actually recognize it as a perfect square trinomial, right? But I never make a big deal out of that if you don't, because you always have a plan B for that. We'll just go ahead and multiply it, factor it out by FOIL, right? Two variable expressions whose product is x squared. Well, that's easy, right? X and x. Two numbers whose product is positive 9, but whose sum is negative 6. So we know they're both going to have to be negative. All right? Notice first times first is first. Last times last is last. Inner product is negative 3x. Outer product is negative 3x. When you combine negative 3x and negative 3x, what do you get? Negative 6x, right? All right, so now we're going to go ahead and apply the zero factor property to 1, 2, 3 factors, right? Let me show you again. So here, this whole thing you consider to be A, this you consider to be B, this you consider to be C. So you have A times B times C equals 0. So obviously either A is 0 or B is 0 or C is 0 or any combination therein, right? Maybe 2 of them are 0, the other one is not. Maybe all 3 of them are 0, but at least one needs to be 0, right? So we say, again, this is an application of the zero factor property. So you say either x squared equals 0 or x minus 3 equals 0 or x minus 3 equals 0. So I wrote that twice, even though you really only need to do it once. But I wanted you to notice something. First of all, notice that you have x squared equals 0. So what number is it that if you square you get 0, right? Well, there's only one number that if you multiply by itself you get 0, and that's 0, right? So here we just get one solution, x equals 0. Now x minus 3 equals 0 gives us x equals 3, and here we get x equals 3 again. Now the point that I wanted to make is when you go to write down your solution set, don't do the following. Don't write 0, 3, 3, because this is nonsense. In sets, repetition is futile. So this is exactly the same as the set with just 0 and 3 in it, right? So we're just not going to write that to begin with, and we're just going to write our solution set as S equals 0, 3. Now, just so you know, we say 3 is a, you know how we call a solution of an equation, well, a solution, it's also called a root. It's also called a zero of the solution, right? That just means one of those numbers that if you plug in, it'll make one side of the equation 0, like the other side. So we say that, for example, 3 here is a 0 of multiplicity 2. So 3 is a 0 of multiplicity 2. What does that mean? That just means 3 is a solution of this equation, not once, but twice. That's all it means, okay? All right. All right, so here's another one for us. It looks like it's ready for zero factor property, doesn't it? Something times something else. There's just one big problem, right? That's not 0. So make sure you don't make the mistake of thinking you're ready to apply the zero factor property. We don't have a 3 factor property. We only have a 0 factor property. So we're going to follow all the steps. We're going to move all the terms to one side, get 0 on the other side. So we have x times 6x plus 7. And we'll bring the 3 over, so minus 3 equals 0. So let's distribute 6x squared plus 7x minus 3 equals 0. Now, always with these, see if there's a GCF other than 1 and get rid of it. Of course, just a constant GCF. And we notice the GCF is 1, so there's no reducing of this equation possible. So, I mean this expression. So we go ahead and try to factor it using FOIL and trial and error. So we want two expressions in these two first spots whose product is 6x squared. So maybe 3x and 2x, and two numbers here whose product is, remember we first don't worry about the sign, so let's just go with 3. So maybe 1 and 3, right? Notice that the inner product is 2x, the outer product is 9x. What we want is we want their combination to give us positive 7x. Okay, it looks like it's our lucky day because we can get 7 out of 9 and 2 as long as 9 is positive and the 2 is negative. So means like a negative here and a positive here. Quick 3-step check. First times first is first. Last times last is last. Inner product is negative 2x. Outer product is positive 9x. They add up to positive 7x. All right. So now we go ahead and apply the zero factor property, which tells us either 3x minus 1 is 0 or 2x plus 3 is 0. So either 3x equals 1, x equals 1/3, or 2x equals negative 3. So x equals negative 3/2. All right, let's get one of our calculator checks in here. Just for, staying abreast of technology as well. All right, so let's go ahead and try this. So what we're going to do is we're just going to plug in for x and see if we end up with 3. So remember, we start with 1/3 and we get out of that group. And now we're going to open another set of parentheses and we're going to put in 6 times 1/3 third, you know, that's going to give us the same result, but of course that's not how I wanted it. It's okay though, it will give us the same thing, but let me just try this. Let's go with one more parentheses, so 1/3, that's probably better. All right, and then +7. All right, so the moment of truth comes when I hit enter. When I do, I should get what? I should get 3, right? And we do. Okay, so now let's see if you remember the copy paste business. So let's go ahead and copy that, and let's replace the 1/3 with -3/2. So every place that we have 1/3, we're going to go change it to -3/2. All right, so we're going to go inside the parentheses, the second one as well, and we're going to change that to like so. Again, the moment of truth, as soon as we hit enter, if it's correct, we should get 3, right? And we do. Okay, so that's a quick calculator check in case we run out of time, don't have enough time, or we don't want our video to last forever. Okay. All right, then here's the last one for the road. You should definitely be able to handle this right now, so I would definitely pause the video and try to get these, and if you do, you should be in good shape. All right, so welcome back. Notice that the x cubed, there's not much we can do with, but we can factor x squared minus 9, right? That's a difference of squares. That's going to factor as x plus 3 times x minus 3. Here we have a quadratic trinomial. We know how to factor those two, right? Well, I think you should have realized that's a special one, isn't it? That's a perfect square trinomial. So we should get x, 5, x, 5, right? So x plus 5 times x plus 5. So now we have 1, 2, 3, 4, 5 factors. We set each equal to 0. So we get x cubed equals 0, x plus 3 equals 0, or x minus 3. And this is a extended application of the zero factor property. And then x plus 5 equals 0, and once again x plus 5 equals 0. So of course the only number you can cube to get 0 is 0 itself. The next equation solved gives us x equals -3. Next one gives us x equals 3. The next one, x equals -5, and the last one also x equals -5. So this means the multiplicity of the 0, which is known as -5, is 2. But we're not going to write it twice in our solution set. In our solution set, we're only going to write -5 once, and then we'll write -3. Then the next number up is 0 and 3. Once again, I personally like to write these in ascending order from small to large, but I also find it as important for you to know that it doesn't matter if you don't put them in order. Okay? Sets are not ordered. And that's basically how to solve higher order equations using factors whenever it's possible. Of course, not all higher order equations are going to be factorable. So there are going to be other techniques which will be developed as we proceed. But for the simplest types of equations which are nice and factorable, it's a powerful technique that will generate solutions for us very efficiently. So that should do it for this video. Stay safe until our next one.